Okay, so that other video cut me off there. Sorry about that. Pick up where we left off here with this problem. So we were just finishing up with saying, how do I get the intervals correctly? And what you're doing again is testing for the area between the zeros that produce a statement that would be true for the inequality. And so when I look at the different areas, I'm saying I need to produce positive because greater than 0 is positive. Now, there's also a little something here that's true, a little pattern going on. And you notice that the signs here, as I tested, actually alternated. Plus, minus, plus. This will always happen, regardless of the problem, whether it's for quadratic, higher exponent, or rational functions. The signs will always alternate on test intervals. So once I determine plus, I don't really need to test the second two. I can tell you automatically it's plus, minus, plus. And I also don't need to start at the beginning, like go left to right. I can start anywhere I want. And if I'm going to start and test a simple number, I'm probably going to test 0 all the time. So I could have started in the middle and tested 0 first, and it produces negative, and I would know automatically that the outsides were plus because it has to alternate signs plus, minus, plus, minus. So keep that in mind as we do the next problem, and I'm not going to test all the areas. I'm going to just test one and then keep the alternating sign thing in my head as I look at the intervals. Okay, let's try something not quadratic. And something not quadratic works in a similar way. Actually, I'm going to back up for one sec. Give you guys a little visual here. We'll do not quadratic in a minute. Hang on, I forgot one thing. And just a visual check, right? If you think about the graph, I overlaid the graph with the number line. And our zeros were at, again, -6 and 1. And if you look at the graph that produces positive values, like when I go out here and we said, yeah, it was plus out here and it was plus out here. And look at where the graph is, right? That's a positive portion of the graph. In other words, that's the part of the graph where the y values are actually above the x-axis. So visually, that idea matches up too. Now, you do not have to do a graph. I'm just saying take a look and see, in terms of intervals, what's going on and how it corresponds to our answers. So, okay, just a little side thought there. Now, back to the other problem. The idea here is, before you start everything on one side, 0 on the other. Then, yeah, I'm going to go ahead and factor. So take out an x. And then I want to do my zeros. Now, zeros are another way of saying solutions. So basically, solve for x. And I'm going to factor it even a little bit further. And really, for these problems, because you're doing test intervals, you should factor completely before you start. Do not go from this point. Always go from all the way factored. So as zeros go, x would be 0, -3, and 3. On my number line, which is really a test number line, I've got -3, 0, and 3. Now, the idea is I don't need to start left to right, and I can if I want. And I can start in any area and test. And testing means just pick a number in that area and plug it in. Now, when I plug it in, again, looking at this point in the problem, and keeping in mind what makes it a true statement. Well, less than 0 means negative. So whatever value I choose, when I plug it in and test, if it produces a negative number, I don't even care about the number, I just want to know the sign. I'm going to say that satisfies the inequality. Okay, now in terms of testing, you can pick wherever you want. And just to prove this idea of plus, minus, I'm just going to pick a 1 right out here. 1 because, pretty simple to work with, right? If you put a 1 in here, you're going to get positive. Put a 1 in here, 1 plus 3 is 4, positive. Put a 1 in here, 1 minus 3, -2, it's negative. Well, positive times positive is positive, times negative is negative. This area checks out. And so the idea here is testing my 1, this area became negative. Now I can tell you for sure that it does this. I don't need to test the other 3 areas. So once you get one area figured out, signs will alternate throughout the rest of the intervals. And then at this point, all I got to do is grab those ones that are negative, and they're going to be my solution intervals. So if you look at the ones that are negative, that's here and here. So my solution is going to be from -infinity to -3 and 0 to 3. In other words, those values plugged into the inequality will satisfy the inequality or will give you a negative number. Again, what you cannot do, the no-no here is do not take them individually. And even though I'm telling you not to take them individually, somebody's going to take them individually. All right, but don't do it. So don't go, well, I'm going to go one at a time. less than 0, and figure them out by themselves, because the problem is what you're doing there is you're actually not really testing what it's telling you. You're not really actually figuring out how the statement will be true or false. Individually is not what you're looking for. You're looking for the combined effect. What happens when I take x times x plus 3 times x minus 3? What's the effect on the sign? Not one at a time. So that's the way test intervals work, and it's kind of a simple idea once you get the hang of it. So again, the process, everything on one side, 0 on the other. Get it factored completely as far as you can. Find the zeros, which are also our solutions, like x would equal what from each factor. Create a test number line, which really is probably a pretty good idea to have that on paper, but then don't test left to right unless the first interval is easy. Pick any spot you want and pick a number, test it. And how does it satisfy the inequality? That's based on what it says. Is it greater than 0 or less than 0? In this case, less than 0 was negative. That's what we're looking for. Okay, let's try the rational ones. I'll show you a couple of those, and then we'll wrap it up and get to a quick quiz review, and you guys can take the partner quiz here in a little bit. All right, so not a whole lot different, actually. There's only one little twist here that you guys got to kind of remember with rational functions, and there's that idea of the domain issue. So when we set this up, we're going to start out the same way. We're going to do 0 of the numerator, and we're going to do 0 of the denominator. And again, these steps are in your book, page 79, so you don't need to copy them down. Just take down the problem. And 0 means if I solve the numerator and denominator individually, what would I get? So if I solve the numerator, I'd get 5, right? If I solve the denominator, and again, this does not need to be done on paper, probably just going to do this in your head, I get 3. And what those are my zeros. So we're going to go, I get negative 3. So negative 3 and 5 creates my test interval. If I'm picking an area to test, and this is the same as quadratic and higher exponent, wherever you like, it's going to alternate plus minus, plus minus. So if it's me, I'm probably picking 0, because 0 is always easier to do than pretty much anything else. Now, when you do this, and you're looking to satisfy the inequality, it's division. So when you plug in to here, and you plug into here, you've got to say sine divided by sine produces what? And what I'm trying to produce, or what it says, is less than or equal to 0 or negative. Now the equal to part, that's fine, but really we're looking for negative. So if you take 0 and plug it in, and check it out, well, 0 minus 5 is negative 5, so that's negative. And 0 plus 3 is 3, so that's positive. And negative divided by positive is negative, which means everything in this area produces a negative solution, which actually satisfies the inequality. I can tell you right away, plus, minus, alternating. I don't need to bother checking the other areas. Now, again, what that means as far as solutions go is that the area between negative 3 and 5, all those values will satisfy the inequality. Now, the inequality here also has to match the symbol. So in the last couple, we had less than symbol or greater than symbol, which was a parenthesis. There's going to be a bracket, but there's a little bit of a twist here. So when we say 5, we can say, okay, that's included as part of the solution. But when we say negative 3, we're going to have to say, no, that's not going to really be in the interval, because not that it isn't in the area, but it causes a division by 0 problem. If you say negative 3 is okay, then you're saying you can plug it in, and if you plug it in, you get divided by 0, and that's undefined and not possible. So when I state the interval, I'm going to have to parenthesis here, bracket here. Bracket because of the inequality symbol, parenthesis because domain problem. That number causes division by 0. So, pretty much a similar problem to the previous two, just the idea is that you got to watch out for that idea of domain issue and don't just automatically bracket both of them. Okay, I'm going to show you one more of these, then we're going to wrap up the notes and move on to the quiz stuff. So for this one, the difference is not 0 on one side, right? Everything on the other, so I've got to accomplish that, and that actually takes a little bit of extra work. What you're going to have to do is subtract 2 over. Think of it as over 1. Get the common denominator. Well, the common denominator would actually be x minus 2, which means multiplying by x minus 2. Now, there's something you guys want to watch out for that we tend to miss on quizzes and things like that. Distribute the negative. So negative 2x plus 4. Again, all over my common denominator, then clean it up a little bit, and I've got x plus 4 over x minus 2, greater than or equal to 0. That's the one you got to use, not the original. It's got to read 0 on one side. If you try to use the original, it's just not going to give you the right statement, the right answer. As far as the zeros go, -4 from this one, 2 from this one. And when I say zeros, I'm just saying put those things equal to 0 and solve in your head. That's all I'm saying. So putting those on a number line, -4 and 2. Now we're back to the same concept, testing, and when I go down here to the inequality, what's the story as far as, what makes it true or false? Greater than or equal to 0, I'm thinking plus. If it's me again, I'm always going to go with 0 on the number line or on my test intervals because it's just simpler. If you put 0 into the numerator, 0 plus 4 is +4 or positive, and you put 0 in the denominator, 0 minus 2 is -2 or negative. Positive divided by negative is negative. And again, sign alternate, so I don't even need to test the others. I can tell you automatic. Which areas satisfy the inequalities? Well, again, we were saying plus was the deal, so it's here and it's here. So solution intervals are going -infinity to -4. Now, -4 is in the numerator, and it's an inequality symbol that's got the equal to, so bracket. But 2, division by 0 issue, so we got to go parenthesis, 2 to infinity. Okay, and that's pretty much it as far as the inequality problems go. I think the quadratic, higher exponent, bigger than 2, and rational are the ones that you got to kind of learn, I guess, maybe for the first time, absorb those ideas a little bit, and keep thinking test interval, and that should get you through every problem. But the key is the little tricks, the little differences, right? With quadratic and higher degree, there's not that much of an issue. Just get them factored zeros test. But with rational, you've got to make sure that you catch that little idea of domain problem, right? If one of your values causes that domain problem, it's not going to have a bracket, it's going to have a parenthesis. Okay, so there's the notes for 1-7. As far as that homework from yesterday, just hang on to that, until Monday, and we'll check that and this one together. So up next will be a video with a little short quiz review. Also, before the sub does the quiz review, he'll get you in partners. And then we'll do the review and take the quiz, and that's kind of it. Anytime that's left, you guys can be working on the homework.